Hello student, this is Ranveer Singh, Associate Professor, Department of Mechanical Engineering. Welcome you all in the renowned university, Jaipur University. Now you are the part of this university, so we will discuss our topic of engineering, drawing and design lab. In this lab, basically this lab is drawing and design of any object. So how we can draw an object, and before design, first of all we have to draw an object on the paper. So in this drawing or design lab we will discuss how we can produce an image of any object, and that image is called projection. So first we will discuss the introduction of the engineering drawing and design, and then we will discuss after that projection of any object. So when we discuss a drawing, there is two things. We think the image of any object as the drawing, and drawing is basically divided in two parts. One is the artist drawing and second is the engineering drawing. Artist drawing is the based on the imaginations, and the engineering drawing is the based on the calculations. Engineering drawing again divide in two parts. One is the manual drawing and second is the CAD. CAD is the computer aided drafting. The manual drawing with the help of the instruments by the manually, and the AutoCAD is the drawing by the help of the computer. So engineering drawing, the definition of engineering drawing is engineers can explain his ideas in the language of lines or the graphical representation. So the engineering drawing is basically the language for the engineers. So what you learn in this course, how the industry communicate technical information like the visualization of an object, the graphical theory or the projection of the object, the standard size and shape of the object, the conventional material of the object, tools which are using to draw and design of any object, and what is the application of that object. These things we will learn in this course. So these are the applications of this course in the several branches. In the mechanical engineering, we can draw and design of the machine parts. In the civil engineering, we can draw and design the construction work. In the electrical department, the circuits, electrical circuit can be drawn with the help of this. So there is the several use of this engineering drawing in the engineering field. So we will introduce, or we will discuss the introduction of the engineering drawing. Before the manual drawing, there is several instruments we are used in the engineering drawing, like drawing board, drawing sheet, T-square, mini drafter, instrumentation boards, scales, proctor, drawing pencils, eraser, sharpener, duster and drawing clips. These are instruments used for drawing in the engineering drawing and design. So first, engineering board and drawing sheets. So engineering board, there is the standard dimensions of drawing board and standard dimensions of the drawing sheet. So D-note, if we are using the D-note drawing board, the standard dimensions is 1500 into 1000 into 25 mm. So the length of the drawing board is the 15 mm, and the width of the drawing board is the 1000 mm, and thickness of the drawing board is the 25 mm. If we are using the D-note drawing board, then we have to use A-note drawing sheet. The standard dimensions of A-note drawing sheet is 841 into 1189 mm. So the three-dimensional board, length, width and thickness, and there is two-dimensional of drawing sheet, length and width, because the thickness is very low of the drawing sheet, just like a paper, so we will neglect the thickness of the drawing sheet. So there is the standard dimensions of drawing board and standard dimensions of the drawing sheet. If we are using the D1 drawing board, then we will use the A1 size of drawing sheet. If we are using the D2 drawing board, we will use the A2 drawing sheet. If we are using the D3 drawing board, then we will use the A3. If we are using D3 drawing board, then we will use the A3 drawing sheets. So that there are the standard dimensions of the drawing board and standard dimensions of the drawing sheets. T-square. T-square is generally used for draw the several parallel and perpendicular lines. So T-square is generally used for several parallel and perpendicular lines in the engineering drawing and design. Another instrument is mini drafter. Mini drafter is also used for draw the several parallel and perpendicular line, but it is more accurate than the T-square. It is used to draw any inclined line at 360-degree angle. So the mini drafter is more accurate than the T-square, because T-square is generally used for draw the parallel and perpendicular lines, but mini drafter can draw the inclined line also. These are the another instruments is the protractor, scales, mini drafter, clipboards. One is another instrument which are using in the engineering drawing and design, that is engineering pencils. So generally we are use a single pencil, but in engineering drawing there is 18 type of pencils. That is called the grading of the pencils. So the grading, how we can grade the pencils? The pencil start from H to 9H and B to 7B, and the center of the pencil is the F and HB. If the pencil start from H to 9H, it will be hard, and the hardest pencil is 9H and very light pencil is 9H. If the pencil from F to 7B, so the 7B is the very soft pencil and very dark pencil, and firm F is the firm pencil and HB is the normal pencil. So there is 18 pencils generally used in the engineering drawing and design. Before starting the drawing, there is the standard which are using in the engineering drawing and design, the American National Standard Institute, ANSI. Drawing sheet size is decided by the ANSI. Line convention and lettering is also decided by the ANSI, and the dimensioning and tolerances also is decided by the ANSI. Then ISO, JSI and BSI, these are the standard we have to follow to draw and design of any object. So as we have discussed, the engineering drawing is engineers can explain his ideas in the language of lines or the graphical representation. So it is basically a language which are using by an engineers. So every language have some alphabets. So in this subjects, in this language, the lines are the alphabets. So the several type of lines we are used in this language. So first we will discuss the type of lines like continuous thick line, continuous thin line, straight zigzag line, freehand line, dash line, chain thin line and freehand line. So these lines have the special applications, and every line has a special purpose. Like continuous thick line, the application of continuous thick line is the visible outline of any object. Continuous thin line, the application of continuous thin line is the imaginary part of any object or dimensioning part of any object. Freehand line or continuous thick line is used to show the continuity of any object. If the object is very big and we have to just draw a specific part of that object, so remaining part we have to show that straight zigzag line or freehand line. Dash line, if some part is hidden, that part is in the object but that is not visible, so we have to draw that part by the help of dash line or hidden line. Chain thin line is the show the center part of any object. First we start the drawing from the center of any object, so we have to draw the chain thin line, the vertical chain thin line and horizontal chain thin line. These lines are intersect to each other, that point is the center of the any object, so we have to start the object draw from that center point. So in this example we are showing the several lines are using in these examples, like some of the hidden lines, some of the visible outlines, and D1 is the straight zigzag line, and the continuous thin line, and chain thin line. Now we will discuss our topic. Today's topic is projection. What is projection? Projection is the image of any object. In the engineering drawing and design, basically we have to draw an image of any object, so that image is called projection. For projections, three things are necessary. One is the object, observer and plane of projections. What is our object and who is draw the drawing, that is the observer, and where we have to draw the drawing, that is plane of projections. Suppose we are drawing a fan, so the fan is our object, and if I am drawing that fan, so I am the observer, and the paper where we are drawing the fan, that is the plane of projections. For example, if you are in front of mirror and you are looking yourself in the mirror, so you are the observer and your image is produced on the mirror, so that image is you are the object and you are the observer also, and the mirror is the plane of projections. In second examples, if we are taking the selfie, so the mobile screen is the plane of projections and you are the object and observer. If you are clicking a photo, then your mobile is the plane of projections, you are the observer, and that object which is image producing the photo, that is the plane object. So there is three necessary things are required to produce a projections: object, observer and plane of projections. So there is three planes. One is the horizontal plane, second is the vertical plane, and third is the perspective planes. So any object have the 6 views. Any object have the 6 views. One is the front view, the face side, and the top view from the top side, left hand side view, the left hand side view, right hand side is the right hand side view, back side view and rear side view. So the 6 views of any object is the front view, top view, left hand side view, right hand side view, back view or rear view. So maximum we can draw the 6 view of any object, that is the top view, front view, left hand side view, right hand side view, back view or rear view. But in engineering drawing and design, generally we will draw the 3 views of any object. The more important views is front view and top view, and maybe right and left side view, because generally in the symmetrical object the front view and rear view is the same and top view and bottom view is the same. So generally we will draw the 3 views: front view, top view or left or right side view. So front view, is generally drawn on the vertical plane. Top view is generally drawn on the horizontal plane, and side view is generally drawn on the perspective plane. These planes are perpendicular to each other, like your furs and walls have the 90°. So these planes are perpendicular to each other. But our paper is the two-dimensional paper. So how we can draw a three-dimensional object on a two-dimensional paper? For that we have to open these planes in the rotation. If we will rotate the horizontal plane in to 90°, it will be just parallel to the vertical plane, and perspective plane again rotate to the 90° right, it will be just parallel to the vertical plane. So in paper we have to draw the reference line XY. That reference line say that the upper part is the front view and lower part is the top view, or you can say the upper part is the vertical plane and lower part is the horizontal plane. Again we have to draw a Z axis. That Z axis again divide that paper with the perspective plane. So the paper can be divided by the reference line in the form of vertical plane, horizontal plane or perspective planes. If the object is very big, then the observer can rotate and move and show the all views of the object, like front view, top view, side views and rear or back view. So the object may be 360° angle in the universe. Object can lies 360° angle in the universe. So that 360° angle will be divided in equal 4 parts, and each part is called quadrant. The first 90° is called first quadrant, then 90° to 180° part is called second quadrant, then 90° to 180° to 270° is called third quadrant, and 270 to 360° is called fourth quadrant. If the object lies in the first 90° or first quadrant, we will say first angle projection. If the object lies from 90 to 180°, we will say the second angle projection. If object lies from 180 to 270°, that is third angle projection, or if the object lies from 270 to 360° angle, we will say that is the fourth angle projection. So there is first angle, second angle, third angle and fourth angle projections. So the horizontal plane and vertical plane intersect to each other, and these planes divide the 360° into the fourth quadrant, first quadrant, second quadrant, third quadrant and fourth quadrant. If a object above HP and in front of VP, it means the object lies in the first quadrant. If object above HP and behind VP, it means the object lies in the second quadrant. If object below HP and behind VP, it means the object lies in the third quadrant, and if the object lies below HP and in front of VP, it means the object lies in the fourth quadrant. So the object lies in the first, second and third or fourth quadrant. It means we can say the first angle, second angle, third angle and fourth angle projections. Due to the rotation of horizontal plane, the vertical plane and horizontal plane overlap to each other, and due to this rotation, the front view and top view overlap each other, so you cannot get the actual dimensions of the object. So generally in the second angle projection or third angle projection cannot be drawn in the engineering drawing and graphics. So remaining two projections, first angle and third angle, will be drawn in the engineering drawing and design. First angle projections. What is the condition of first angle projection? In the first angle projections, object lies between the object and observer. So in that case, object lies between the object and object lies between the observer and plane of projection. In that case, the front view draw the upper side of the reference line, top view draw the bottom side of the reference line, and left hand side we draw in the right side of the front view, and right side draw in the left side of the front view. Vice versa, in third angle projections, the conditions of object is plane of projections lies between the object and observer. If the plane of projections, if the plane of projection lies between the object and observer, in that case there is a conditions that plane of projection should be transparent. So, if the plane of projection transparent, that condition is required for draw the third angle projections. So, what is the position of the front view, top view and side views? In this case, the top view draw the upper part of the reference line, top view draw the bottom side of the reference line, and left hand side view draw in the left hand side view, and right hand side view draw in the right hand side view. So, how you can identify this is the first angle projection and third angle projection? If the front view upper side of the reference line and top view the bottom side of the reference line, that is in the first angle projections. In third angle projection, the front view draw on the upper side of the top view will be draw on the upper side of the reference line, and the third angle projections, how we can identify the third angle projections? The front view draw the bottom side of the reference line, and the top view draw the upper side of the reference line, and left hand side view or generally draw in the left hand side and right hand side view in the right hand side. So, this is our topic, projections. Next, type of projections. In the engineering drawing and design, two types of projections, orthographic projection and isometric projections. What is ortho? Ortho is a Greek word. It means perpendicular. So, the orthographic projections means projectors are parallel to each other and perpendicular to the plane of projections. When the projectors in the sense of rays are generally perpendicular to the plane of projections. In orthographic projections, the three-dimensional objects draw in the two-dimensional drawing, that is orthographic projections. And second is the isometric projection. If we have to draw the three-dimensional object into the three-dimensional drawing, that is called isometric projections. In orthographic, we get the actual dimensions of any object, but in isometric drawing, we get the less dimensions of the object. In orthographic, front view we generally calculate by the help of two dimensions, one is the length and second is the height. In top view, we will calculate the two dimensions, one is the length and second is the thickness. And in side view, we generally calculate the two dimensions, height and thickness. So, in orthographic, in any view, we will get only two dimensions, and all these three views complete information about the actual size and shape of the object. In isometric drawing, the object, three-dimensional object show in the three-dimensional drawing. So, the exact size and shape cannot be drawn by the in isometric drawing or projection. So, in engineering drawing, generally draw by the orthographic projections. So, thank you. We will discuss the next lecture of sectional view of any object.